Blueprint. Introduction to Unreal Object-Oriented Programming and Blueprint. So, why are we covering Unreal Engine? Um, yeah, why are we covering Unreal Engine? Because a lot of people asked to do Unreal Engine programming. So, UE4 programming it is. What we're gonna do? We're gonna cover Unreal Engine, what it do, how it do. We're gonna cover like programming concepts. So object-oriented programming concepts. Oopsies, a common occurrence. I'm literally not going to get reelected because of this. Classes, functions, variables, public and private stuff, inheritance, interfaces, casting, and references are things that we're going to talk about today. The PowerPoint only covers like a chunk of these, and I'm going to do my best to like explain the rest on the fly. I really like having a well-organized PowerPoint for this stuff, but man, PowerPoints take a while to make like to a really high standard of quality. So that's all right. And then we'll talk a bit about blueprints and how those work. The blueprints in Unreal Engine are like the fundamental like class. You know, you call it a class. It's the Unreal Engine calls it a blueprint. And we'll learn what that is if you don't already know, and that should be good. So first things first, Unreal Engine. We can do this in a different order. So if you don't want to do this right now, we don't have to. But everyone should launch Unreal Engine right now, if you can. Does everyone here have it installed? Shout out to Discord for exploding. Be right back. Oh, rip Marissa. Okay. Does everyone in here have Unreal installed? Does anyone not? Is a better question, I suppose.
Yeah. I don't. I'll just kind of follow along.
Sick. Sounds good. That's fine. Okay. No worries. Yeah. All I'm doing here is saying like, hey, let's make a new blank project. When you make a new project in Unreal Engine, you get these options. And one of the options is like maximum quality, which is a bit misleading. But Michael, my PC can't handle maximum quality. The main difference between maximum quality and scalable, which is the only other setting in there, is literally one graphics setting, anti-aliasing. It's really weird. Like, doesn't make any sense. Just Unreal Engine being quirky. And we don't want to sacrifice anti-aliasing. That's why you keep this on maximum quality. No starter content prevents the project from starting with these two orange chairs, a vase, and a table. Which, why would you want that? It just gives you a proper blank project. Except the project isn't blank. This is the Unreal Engine interface. And when you start a project, it's not blank. Bruh, why are there things in my empty project? It starts you with default lighting. It starts you with a spawn point for the player. It starts you with a reflection capture, which is like a thing that takes a 360 image on its position and then projects that 360 image onto the reflections of all the objects nearby so that they kind of absorb the ambient lighting in the form of reflections. And then it gives you this like cloud and atmospheric lighting effect that like, if you delete them all, you'll end up with like a pitch black world. And you're welcome to delete them all. So yeah, as if people created a project at this point, the Unreal Engine takes a while to load up, and I for those of you that are going to follow along, I'd love for you to have it running in the background, but don't worry, I won't go too fast. I'll just like pause for a second to let people like create a project. Feel free to delete all of these, make it like a little black world. Just empty blank project, blueprint, maximum quality, no starter content. Not very many settings here. Hell, I think that's their default settings, so you should be fine. And your project should look like this. All these objects are examples of actors. So this is where we get into programming concepts. I wish I could do like hand raising stuff, but it'd be cool to know like who here has no clue with programming, because this sort of targets those people. Is there like is anyone here clueless with programming? If you're not, then like dang, because I was sort of targeting that, just object-oriented concepts, inheritance and stuff. If everyone knows that, then this PowerPoint suddenly became pretty irrelevant. But you know, a lot of people complain that they don't know game programming in our club. So it's like, I feel okay. All right. No one's responding. I'm assuming everyone just vaguely. I'll run through it anyways. Cool. Object-oriented programming. So code. What's code made up of? It's made up of mainly functions, variables, and like inputs and outputs, I guess. And like inputs, like me doing something, you know, is going to kick off a function, whether that's like hitting the start button or like compiling the code might just like run down the code. And functions change variables and ultimately kick off outputs, like probably changing what's displayed on your screen. So what's a variable? A variable can be like an integer, which is just like a round number, a float, which is a number with a decimal, booleans, which are just true or false, you know, zeros or ones, a string, which is a bunch of text, and it can be more complex. They can be like a reference to a complex data type, any complex data type for that matter, vectors, objects, anything you can imagine might be considered a variable. So what is object-oriented programming? It's the idea of grouping variables and functions together into objects. So for example, like a car. A car might have the associated variables of the gas that it has in it at any given moment, and maybe the top speed and acceleration. And simpler things like location, rotation, velocity, you know, at any given moment, like is it moving quickly? That's interesting stuff. And then you might have a function like drive forward, which every time you fire it, subtracts from gas and adds to the velocity of the car by whatever the car's like acceleration variable is. Or turn right might change the rotation of the car and reduce the velocity maybe every time you fire it off. So that's kind of the idea here. You take these functions and variables and you combine them under the word car, and now this car like groups them together. So why is object-oriented programming good? It makes a lot of sense. You know, it just makes sense to kind of organize things this way. And huge complex projects need it. Why? Because of encapsulation. Encapsulation is this idea that that the object is a neat container for everything that makes it up. All things car are going to be contained within the car. The code that describes how it moves, how it behaves, how it reacts to things should all be contained within car. The reason why is because, like, well, what's the alternative? The alternative is that you have like this one massive file that describes good. That's cool, Marissa. Unreal Project is on the way, so code discussion is good. Yeah. If the alternative to encapsulation and keeping things organized in objects is the idea that like you have everything in this one giant file that describes what happens to your game every frame. Like, okay, you know, every frame we're going to like update the car's position and the car's like variables and maybe the player's code and maybe the code about the fish AI in the background. You know, so Blueprint, Jeremy, Blueprint. I'm not going to cover C++ just because again, I'm targeting beginners here, and I think Blueprint's also really worth learning because it's even if you're doing C++ already and you're comfortable with C++, Blueprint is kind of like doing C++. It's equally efficient. It's like one-to-one. You guys will see. There's like no downside to using Blueprint at all. At all. There's no freaking downside to using Blueprint. Not like almost any. The downsides are evident very late in a project and won't like come back to bite you almost ever. In fact, you can mix and match Blueprint and C++. So if you set your project to be Blueprint, it can be you can still do things in C++ and vice versa. Anyways, sorry guys. So players shouldn't be one massive, super complex file for all the info that happens when the player's in the car, and maybe what happens when the player's in an airplane, and what's happening to the fish in the background, and the clouds or something like, and the enemies. It shouldn't all be mixed together in this one giant jumble of code. Keeping them separated is very nice. We keep the code nice and neat, separated, encapsulated. That's the vocabulary there. There's another thing that happens with object-oriented programming, and it's the idea of inheritance. So inheritance is like, okay, you programmed the nasty physics behind car tires, like torque and friction and springs and all that. And now you want to make another car. And it's like, okay, do I have to start over and maybe like I finished my Lamborghini, now I want to make my I don't know, uh, McLaren Spider, or my BMW i80 whatever. Like, do I have to do it all from scratch? No. What you do is you make like an abstract class called car. I won't say abstract class. That's confusing. You make like this big object at the top that's like, okay, this is the car, and then you create things that inherit from car. So like Lamborghini inherits from car, and when a Lamborghini inherits from car, it gains all of its properties and values, but can make some changes to them and add new features to them. So object-oriented programming lets you do this. Inheritance is a big part of it. So let's look at inheritance for a second. Here's like an example of how inheritance might look in Unreal Engine, and it uses some of the vocabulary that is common to Unreal. So this is a good thing to understand. Um, there's an object, right? An object is like the core thing that everything inherits from. Unreal Engine calls them U objects, and the reason why is because a U object is one level above. One level above like your standard C++ pure object. It is a object that's recognized by the game engine. It just has some code that you will never see or touch. That's just saying like, hey, recognize me. It's engine stuff. You don't have to worry about that. And then there's actors. So an actor is like an object, but it can exist in space. It has a location, a rotation, a scale. It exists in our game world. And then from actor inherits pawn, and maybe car. So pawn is like one that already exists in the engine, and it's an actor, but it additionally has properties related to a player controller, which is this other type of class that says, hey, you can receive the inputs from a player, essentially. Meanwhile, car might inherit from an actor, and it might have properties like a collision box, and that it's physics enabled. And it has a variable called top speed, and a variable called fuel, and a function called drive forward. And maybe it has a static mesh that's like what your car will look like. And then from car might inherit Lamborghini Murcielago and McLaren Spider and Nissan Rogue 2018. All the different types of cars would inherit from that. From pawn, you might have an enemy, a player, an NPC, and they all have different properties, but they all inherit the same fundamental properties that define what a pawn is, which is it has like a player controller, and it has a scale and a rotation and a location, and now you give it details like its state of behavior and how alert it is if it's an enemy, and what it's currently targeting, and what the last known position of its enemy is, so that it goes there. And from there, you might have a Goomba or the scavs in Tarkov. Inheritance.
Excuse me, Michael.
Sure.
So the car in the last example, so was that like a component in Unity kind of thing, or like,
Um,
or like, what's the difference between car and pawn in particular?
a car is a class that we defined that inherits from actor and it has the properties of location, rotation, and scale from actor. In Unity, um, you like attach scripts to things, which is strange to me, and is a sort of has a versus is a mode of inheritance that I was going to discuss in a second. Um, but you can also definitely make your own like classes and objects in Unity. I don't understand what a component is in Unity terms. That's not. But you know what? I'm sure other people will be asking that question, so let's answer it. Components. Let me just take a quick look. Components in Unity. Introduction to components. A game object is an object in Unity which contains components. Components define the behavior of that game object. Okay, makes sense. Yeah. In Unreal Engine, they're called components in Unreal Engine as well, but this isn't components. So we'll talk about that. Yeah, a component can probably be a game object, right? Like a game object can have other game objects as components for that game object. I'm assuming. And Unreal Engine does that as well. We'll talk about that.
Okay.
But yeah, components. This isn't a car is a game object. Okay, so this is like game object, and then maybe we have like an actor that inherits from the idea of game object, and then we have a car that inherits from the idea of actor, and a Lamborghini inherits from car. Um, that's like a universal concept. It's not a pure Unity concept. It's not a pure Unreal Engine concept. Unreal Engine just would call Unreal Engine has this pawn thing, and it has this actor thing in it, but that might exist in Unity as well. It should exist in every game engine. Like this basic hierarchy tends to find its way everywhere. And then this idea of like inheriting from a hierarchy like this is a very like natural occurrence. It happens in any like game development or software engineering in general. Like it's just inheritance is a very universal concept to programming because almost all programming these days is object oriented. Well, a lot of it is. Anyways, so far we know that objects wrap up code, functions and variables, right? Objects can inherit from other objects, and a variable can be an object. Okay, wait a second. Objects wrap up code, which is functions and variables, and a variable can be an object. So objects can have objects inside of them. What does inside mean? Okay, so objects can contain other objects. This is important. This relationship is a relationship. It is a car. Lamborghini Murcielago is a car. That means it has all the properties of car. However, Lamborghini Murcielago has a V12 engine, which is an engine, which is an object. This is something that you can sort of do. There's different types of inheritance. There's has a and is a, and has a isn't really inheritance. Sorry. Yeah, what this means is that that you can put your Lamborghini in your 14-wheeler. This means that the Lamborghini can inside of it in like its data be like, hey, I have a V12 that exists with my copy of the Lamborghini, and this V12 engine has this data associated with it. Maybe it has fuel consumption rate, horsepower, responsiveness, CO2 emissions. And then the Lamborghini, whenever the Lamborghini is told to accelerate, it might instead fire off a function on its own engine that says, hey, rev the engine. And then the engine will say, you've emitted this much CO2 and stuff, and then the Lamborghini processes that. Like, you get these relationships happen in programming. So classes versus objects. This is important vocabulary. Class is referring to the code. It's the template. An object is a class that has been instantiated. So you make a class called Lamborghini, and then you instantiate a copy of that class, and like in memory, it starts to exist in the program. So until you do that, it's like not actually it's not running. It doesn't exist in the world or in the memory of the program that's currently executing. So instantiated means it's been spawned, it's breathed into existence. In more pure terms, that just means adding instance to memory. But in game engine terms, that typically means like placing it in the universe. Like a 3D representation of that object tends to starts existing in the 3D world. So this is an example of what code like that might look like. You might say, my Lamborghini that I named and now exists is equal to new Lamborghini. And now you've created a object called my Lamborghini that I named and now exists that is of the type Lamborghini from the Lamborghini class. And then you can call a function on that specific instance. This should hopefully clarify has inheritance, like has an engine, works like this. The car class might have code that says, hey, a new engine object, it gets instantiated every time you create a new car. And now the car can say my engine dot rev or something, and then work with that. You can have like an engine that's associated with the car if you have an engine object. Enough theory. Let's go to application to clarify some of these things, because I'm sure it's a little much for anyone that's watching and doesn't have experience with programming. We're going to give our world lighting again. We're going to make a new blueprint. Blueprints are like classes in Unreal Engine. and then we're going to create an instance of that blueprint in our environment, and we're going to give it some behavior, like maybe turning the light on or off. Marissa describing the .rev API in the chat. So yeah, this is adding just some lights back into the world. A little side note about how lighting works in Unreal Engine. You can see me here dragging atmospheric lighting into an empty world. Creates this beautiful background, like atmosphere looking thing. But atmospheric lighting isn't real lighting. When I add this cube into the world, you can see that the cube is this purple glow, and no matter what time of day it is, the cube stays the same color because light in game engines is a bit complicated. Light in game engines doesn't actually work like it does in real life. You have to define like a very specific light source, and there's like a couple fundamental types of lights: spotlights, point lights, skylights, which just paint an ambient light onto every surface that's facing upwards or sideways. Directional lights that are just like the sun, this global light that's coming from one very specific angle. Yeah, so lighting in video games is not quite true to life. It's not like every surface that emits light, like this background, this skybox that we're kind of generating here. That doesn't actually emit light that interacts with objects unless you have ray tracing on, and that's a different ball game. But yeah, so let's get started. Let me crank something out in Unreal Engine. Let's do this. So here's oopsies. Object-oriented programming concepts. I'll wait for that to launch. Has any of this been even remotely insightful for anyone? Probably not, because everyone here has that programming background already by the looks of it. That's fine though. Let's see. Let's see. Any minute now. Yeah, Unreal Engine takes a second to launch. It do. But no doubt in a few seconds. Oh, it's at 0%. Oh, 6%. Okay, here it goes. 9%, 17%, 39%, 45%. Why? It's taking a second. Ooh, it's trying. It's really taking a second. I'm kind of surprised. I launched this earlier today. It opened pretty instantly. 45%, 50%, 70, 80. Any minute now. Come on. Come on. Come on, do it. Get on my screen, come on. Come on. 86%, 90%. Oh boy. There it goes. Alright, and there it is. There's the editor. Alright, Unreal Engine. So, here we go. We're in Unreal. Let me delete everything like I said to do. These are all just actors, right? Because they exist in the 3D world. We got static mesh actor, which is nothing but a static mesh that has this material applied to it. Today's lecture is intended to cover like Unreal Engine a little bit in addition to programming, but with like an emphasis on programming. We got skylight here. Go ahead and delete that. Sphere reflection capture actor. Delete that. Sky sphere. Sky sphere. You'll see it's like a BP underscore sky sphere, which is referring to blueprint. This is a giant blueprint class that's been instantiated, and it has all this like crazy code associated with it. That's like pretty intense, and describes like how to update this material. And the material is this giant material instance, which is pretty cool, honestly. Where is what material did they set it to? I don't even know. Construction script. Here it is. M underscore sky underscore panning, which you can't see unless you turn on show engine content. And then yes, it's interesting. M underscore sky underscore panning. I'm just kind of curious. Let's take a look at that engine content. Uh, M underscore sky underscore panning. Take a look at this material. Yep. Yeah. So this is what's generating those clouds that we see in the background. In fact, here it is. You can see. We can see a little bit of that like cloud noise on the surface here. These little white particles that you can kind of barely make out. This is what we're seeing. Very cool. Very cool. Very, very cool. All right. Anyways, enough of that. That's what's generating this effect, this giant sky sphere effect, which literally is a giant sphere. If we fly out really, really fast, you can see it's just a giant sphere that our level exists in. And in the background is atmospheric lighting, which isn't even, we can delete it, and it still kind of looks the same when you're inside of the sphere. It's only a little bit translucent. So let's delete the sky sphere, delete the player start, and all that remains is this light source. So remember what we were saying earlier about lighting in video games? There is a light source right now, but the world is black. And funnily enough, I can delete the light source and add atmospheric lighting, and the world will be bright, but there won't be any light in the world. This light source is defining how objects are actually shaded. Like that cube is actually responding to the direction of my sunlight. Whereas when I introduce atmospheric lighting, okay. Oops, let me just add that back. There we go. Whereas when I introduce atmospheric fog, it does that, but that's not actually affecting my cube. So just distinction about lighting in games. Something that I think is important to get out of the way, like right off the bat for someone that's new to game development. Yeah, so let's make an object. We've got our cube here. Let's not worry about the cube. Actually, let's delete that. I'm gonna go down here into the content browser. That's what this area here is, and it contains all the assets that we're gonna be working with. I'm going to right-click and create a basic asset. I'm gonna click Blueprint class. You can see Unreal Engine, I've said this before, I'm gonna say it again, is filled with tooltips. Tooltips that hugely help you if you're learning the engine. In Unity, you probably have to go Google stuff. In Unreal Engine, if you mouse over anything, it'll have a tooltip, and that tooltip will be pretty verbose. And some of them, like this one, says hold Control plus Alt for more. And if you do that, it gives you a very verbose tooltip about what everything does. Like Blueprint class, there we go. Is an asset that content creators can use to easily add functionality on top of existing gameplay classes. Often shortened as just Blueprint, blueprints are created inside of Unreal Editor visually instead of typing by code, and saved as assets in a content package. They define a new class. They define a new class. Oh, this is a Blueprint class. So let's go ahead and make one. And it immediately asks us, pick a parent class. So what it's asking us is it's asking us, hey, where along this tree do you want to inherit from? Do you want to just inherit from object and do nothing? Do you want to inherit from actor and have something that exists in the world? Do you want to inherit from pawn so that it has all the properties of actor but also player controller? That's what it's asking us. And you can actually see the entire pre-existing tree diagram displayed as a drop-down menu tree. So we have actor, which inherits from object, and then what inherits from actor? Well, pawn inherits from actor. And then, down here, character inherits from pawn. And then there's like a couple different types of characters. So yeah, there's a lot to work with here. But the basic ones are actor, pawn, character, player controller, yada yada. Let's go ahead and make an actor, which is the most basic one. It's just an object that can be placed or spawned in the world. You can even open the documentation with that little link right there. And it'll take you to the docs, and oh wow, we got a 404 error. That is comical. I swear Unreal Engine's a really good engine, guys. Colin Davidson said it today. Actor. I'm gonna call this my car. Yeah, my car. And you know what? I'm going to add I'm gonna add geometry to the world. This geometry thing. I'm going to do box, and I'm going to go ahead and make its x and y be like 20,000 by 20,000. This should be really interesting. I feel inspired. We're gonna program a car from scratch. It's gonna be great. This might be ridiculous. We'll see. And yeah, what this does is it just creates some geometry in the world. And when we spawn, we collide with it. Notice when I hit play, look over here. It spawned all this stuff. Why is that? Why did it do that? There's a bunch of default settings that you can play around with over in project settings about what happens when you hit the play button. And it instantiates all these like data-driven classes as objects, like this game network manager, game session, game state base. These are interesting things that you can look into on your own, but they're not things that you should worry about for now. They don't really affect you in any way. Essentially, when we hit the play button, it instantiated something that they call the default pawn, which is just you flying around, and WASD EQ is like controls, and you collide with the world, and that's it. It's the default pawn. Anyways, my car.
Excuse me, Michael.
Yes.
What atmosphere did you put into the world?
I went over here the like place actors tab, and I went to you go to visual effects, and I put in atmospheric fog. Exponential height fog will also look good. You use either. Atmospheric fog is a little bit less computationally intensive, I think. Exponential height fog attempts to perform volumetric effects as well. Yeah, creates more density in low places of a map and less density in high places. Atmospheric fog it simulates atmospheric light scattering through a planetary atmosphere. This is true. It is literally a planetary atmosphere. We can zoom really far out, and it'll be like the size of a planet worth of atmosphere, and it's simulated all the way out to like space. For the game jam that I did with Tony and Hannah over the summer, we put one of these like 1,000,000 kilometers away in the background to look like a planet from like a spaceship's perspective. Gave it a purple atmosphere. It's really cool. But here we are.
My cube is stretching.
Your
like,
cube is stretching.
Or rather, like my view of like the cube stretching. It's like I'm looking through like a mirror, like a glass. I'm just wondering like how to fix that.
You should share your
So, like,
screen.
if I look up and down, it just like stretches.
You should share your screen.
Okay. Hold up.
Is it? I bet it's. Is it this? Is it like this effect?
It's probably something simple, but I just don't know what it is. You know?
If it's
like that.
it's probably the field of view slider somehow. But I'm looking at your screen. Let's take a look.
Same thing. It's same effect. So
Okay.
what is
Yeah,
going
that's
on?
okay. So that's just field of view. Yeah, that's what you're experiencing is like camera distortion with field of view. When you have a very vertical screen like that, you're going to experience distortion because you have a really high vertical field of view relative to the horizontal field of view.
Okay.
Okay,
So it's because of this panel.
It's because of how much you've like scrunched up the panel. Yeah. And you're more than welcome to like rearrange the interface in a way that benefits you. Like you have a pretty weird interface right now. It looks like you moved stuff around a lot, which maybe
No, I just moved one thing, honestly. But,
your modes panel is on the right instead of the left. Your content browser is on the right instead of the left. Your details panel is on the bottom instead of the right.
yeah, but I realized that having it vertical would change the how it looks. Like,
yeah, it's FOV. It's
not
FOV.
like that.
It
Yeah,
just
I
does
like
that. You can manually control field of view with a little drop down here. In fact, when you first open the engine, there's a little green circle thing flashing on the top right that says like tutorials, and when you click it, it'll give you a real quick tour of the interface. It's actually so nice. Unreal Engine has built-in tutorials, and they're kind of worth it. Like, welcome to the Unreal editor. Look at this. You click next, it's like, yep, this is the level editor. This is what these buttons do. This is what these buttons do. Then there's the modes panel and the content browser and the details panel and the world outliner. Gives you like the names for everything so we can all use a common vocabulary. And then there's all these other tutorials in there that are like, yep, here's how you code stuff, and here's blueprints. Tips for editing blueprints. Look at that. Class blueprints and level blueprints. A level blueprint is a specialized type of blueprint that acts as a level-wide global event graph. Events pertaining to the level as a whole. Like, it's great. It's absolutely brilliant. Gives you all these like tips and tricks about how blueprints work. But it's actually almost ahead. It's a little bit advanced for us. What we're gonna focus on is really like just granular concepts today. Really like basic concepts. So we have this class here. It's called myCar. Let me delete this cube. The only things that exist in our world now are atmospheric fog. It's an actor that is providing this atmospheric rendering. Light source, which is providing the lighting, and box brush, deleted it, which is providing this giant landscape with collision that we can kind of drive around on. What I did is I went over here to geometry, brought in a box, and scaled up its X and Y properties over here in the details panel. So now, let's add my car to the world. And there it is. That's our car right now. It's not doing too well. Not too hot. But it'll do. It'll do. That's a car. Let's go ahead and open it up. All right. And when you open it up, when you double click down here in the content browser, you get the blueprint editor. And the blueprint editor has all this stuff. It has this viewport tab, construction script tab, event graph tab, and then over here it's like those same tabs are organized with all the different events, a function, all your variables for the class. So all this stuff is kind of on your screen here. Let's get started. Let's see what we can do. Let's add a component. This is the components that we were talking about. So what is a component? It's another object. It's another like object that exists in the engine, and we can just instantiate it inside of this object. So let's add a cube. And we've added a static mesh component that already has a cube put in. And now our car class has a cube. In fact, there it is. It no longer looks like that little circle sprite. Instead, there's literally a cube. And yeah. In fact, I can add more my cars to the world. And see, they have different names, but they're all the same class. They're all the my car class. Now, let's make this respond to something that we're doing. Foremost, let's make this cube the scene root. What did I do there? I dragged it onto the other one, and it like deleted the other one and made this one the root. I dragged it onto my default scene root, and it said make it root, and I click yes. See it one more time. Drag it on there, and it says drop here to make cube the new root. The default root will be deleted. Bam. So now this is like the origin and source of scaling for our entire object. Now, hell, we can add some cylinders. This is really not the way to 3D model, but like, let's do it, right? Why not? Let's add some tires to this sucker. We'll give him a tire on the like left-ish, kind of. Yeah, and then I can actually duplicate this, and we'll give him another one. We'll call this. Can I rename them? I sure can, but only over here. Right tire. And it's important on the bottom left, I see this little thing right here. It's telling me that the positive X direction is that way. So what I'm going to do is make sure that the positive X direction is what we describe as forward. And I'm going to position this right tire, which is just a cylindrical static mesh, down over here. And then left tire, I'm going to position on the left. Let's see, just like that, and like that. And like that. Ooh, the cars do be honking at each other outside. Oh man. Oh, they're angry. Oh, someone's not having a good day. Oh. All right, cool. Tires, yeah. And now let's look at the world and notice they both, they both have the tires. Oh, something's not right with the tires. I actually have this on my other monitor, and you can see that when I edit it, it changes in real time in the world, which is really cool. So there we go. And let's do another thing. Let me rename this to left tire. And just for our own debugging purposes, let's add a arrow. And these are just like for debugging. They're really nice. Just put it in the front there so that we can see which direction these guys are facing. Cool. And now I hit play, and I'm still the default pawn, which is this like spectator pawn that lets me fly around and observe. And these seem to have collision. You know, I'm colliding into the tires here. I can't fly into them or through them. But yeah, we got two game objects there. Great. Let's give him some code. So let's say, let's give him a variable. Let's say, actually, no, let's not do variables yet. Let's look at this event graph. When I click on the tabs here, I can go to this event graph, and there's 3 nodes by default. You can delete all of them if you want. Not really necessary. Let's delete these bottom 2. Let's delete event tick and event actor begin overlap. So all that's left is event begin play. What you can do is this white line here, this like white triangle represents the execution line. This is the order in which code executes. It's like, hey, fire this when this event fires. It's going to fire whatever I attach to the white line. So I'm going to say, actually nothing. I'm going to delete this one too. Sorry. I'm going to right click, and I'm going to type in W key. And there's W, the one that looks like a keyboard here. And there it is, W key. And when the W key is pressed, I am going to get actor. I'm going to add relative location. And the relative location I'm going to add is to the cube. Add relative location to cube. And the relative location that we're going to add to it is going to be forward. We want to move forward. So let's get the cube's forward vector. Let's do get forward vector, which should be the positive x direction. And let's also drag off of this and do get location. Get world location. And now we've got 2 vectors, the world location and the forward vector. And I can say, actually no, oops, because we're adding location, so never mind. All we have to do is say add the forward vector. Let's how much do we want to add? Let's do vector times float 10 forward vectors worth of forward. So when I press W now, are they moving? They're not moving. Why aren't they moving? Why aren't they moving? Well, there could be a few reasons. The idea is that when the W key is pressed, these guys should move forward. However, they're not. And the reason for that might have something to do with the fact that these are not pawns; they are actors. But they should fire off this event. Hold on. Compile, save, play. No, I think what's consuming our input is the spectator pawn that we are. So what I'm going to do is I'm going to add component, and the component's going to be a camera, and the camera is going to go up back here, and player. Let's look up player. Possess. Let's see, camera, lens, color grading, rendering features, tags, activation, cooking, events, physics, camera options. Okay. Yeah, I was intending to make these controllable, but I suppose that is exactly what pawns are for. I forget what the process is from converting an actor into a pawn. What we want to do is we want to make sure that these guys consume our input, right? So that when we press W, they like move forward or something. That was the point of this little demonstration. What I've done here is I've grabbed a reference. This is a reference to the cube component here, and I've said get its forward vector. So it's calling this function on the cube component. The cube component has code in it that says, hey, when someone asks for my forward vector with cube.getForwardVector, I will return my forward vector. And then we multiply that by 10, vector times a float. And then we take that vector and we give the delta location, so that whenever we press W, it adds a location to the cube. However, it's not quite working, and let's see why. Let's do let's see, always relevant, replicates, yada yada, rendering, actor, input, auto receive. Oh, here we go. Auto receive input. That was it. So auto receive input is automatically disabled. Let's do auto receive from player 0. And now we're player 0, by the way. Now when I press W, there he goes. Yeah, he's moving. And he stole the input from the flying pawn, so now I can't fly around, but I am controlling this car. Every time I press W, it moves forward by 10 centimeters. That's cool. That's really cool. Great. Brilliant. Brilliant. Let's add a variable, and let's make that variable be top speed. Top speed. Let's do that. Why not? We're going to literally rewrite the physics engine from scratch here. And I'm going to change it to a float data type. I went up here and I changed it to a float. And you can even add tooltips. You can add descriptions. Unreal Engine comes with like all this stuff that's just convenience, like commenting purposes. So I'm going to say this variable will preserve the top speed of our car. And I'm going to say, I'm going to right click here and I'm going to look up tick. Now, event tick is a event that fires every frame, every single time that the game updates. And additionally, it tells you how many seconds have elapsed of gameplay. So, for example, I can just do a print string, and the string that it'll print is going to be that. And we can just do play, and you can see. Sorry, not how many seconds have elapsed, but how many seconds have elapsed since the last frame. That's what delta seconds is doing. So it's right now 0.01 to less than a hundredth of a second between frames. And those numbers are just streaming down. Every tick number is being printed on the screen. So that's cool. Let's not do that. Instead, what we're going to do is we're going to say, let's get another variable in here, and we're going to call it current velocity. We're just completely programming our own car physics here. And current velocity, whenever we press W, we're going to get current velocity, and we're going to increment it by 1. Sure. Great. And current velocity will start at 0. It's the default value. And then event tick, we are going to do this right here. We're gonna we got the same cube, the cube's forward vector. We're going to do add location, add relative location, and every frame we're going to add location that's going to be the forward vector times the velocity, vector times float, and velocity times time is how much it should move. So times the time since the last frame, right there. And now it's gonna like not move at all at first, but I'm gonna spam the W key. Where is it? I'm spamming the W key and it's accelerating. It's picking up linearly. There it goes. And now it's moving with a linear velocity. And I keep spamming the W key and it's accelerating. So that's great. That's great. That's working. That's really good. What we can do is we can increase the current velocity, not by 1, but by an acceleration feature, and that acceleration feature is going to be unique to our car. So let's do acceleration here, and I'm going to say describes the vehicle's acceleration. And we are going to get acceleration here, and we're going to do float plus float. So we're going to do acceleration plus current velocity set current velocity. So every time we press W, we set acceleration. Oh, that was a multiplication. Float plus float. There we go. We're going to take current velocity and add acceleration to it and set current velocity to that every time we press W. Now let's change acceleration. Let's say this puppy's got like a V12 engine. So every time I press W, yeah, it's speeding. Yeah, really taking off. Very good. Excellent. Okay, great. We had a camera. Where's the camera? There it is. There is definitely a way to make this automatically be possessed. Camera options, use pawn control rotation, maybe not. Let's delete this guy because this guy's the one that's evidently being possessed. And let's do can be damaged, input, auto receive input from player 0, play. Oh, play? There we go. All right, it's receiving input. Okay, cool. There's I don't quite recall how to possess stuff, but that's okay. That's okay because it's not a pawn. We'll figure that out. So, but you should understand like that we're kind of working with the code here. So we're saying event tick every time that the game updates, move our actor forward by the velocity times the elapsed time times the forward direction. Let's add some turning. I'm concerned this is going to consume more of our input, but we can totally add some turning. Let's not do that yet. What else should we add? We should definitely figure out this camera stuff. Hold on. Possess camera on actor UE4. That's what we're attempting to do. Possess camera on actor, working with camera components. Here we go. Possess on player controller, possessing pawns, compile and save. Default pawn class. Right. Yeah. Sure. Game mode base, finished blueprint, compile and save. Making an actor possessable UE4. Let's see. What is convert to possessable? Okay. Converting. Add possessable. Add possessable as a new binding to the sequence that will possess the specified object. No, not quite. Yeah, I'm assuming spawned versus possessable cameras on LinkedIn, just for Unreal Engine. Great. That's all right. It's all right. We'll work with this. Worst case scenario, we need to quickly remake this over in something else, but it should be component activation, user data, class defaults, class settings. Here we go. We can change the parent class. Right. Let's just make it a pawn real quick. So parent class becomes pawn, and now all of a sudden we are possessable. What does that mean? It means that the pawn can not only auto-receive input from player 0, but auto-possess player 0. And now, when the player possesses this actor, it just goes to the camera. Oop, I hit play and Unreal Engine is freezing. Not a good look, not a good look. Come on, Unreal. You can do it. Come on, Unreal Engine, come on. I believe. Oh, it's not having it. Oh, there it goes. Wow, that was, Jesus, what a lag spike. So now we've possessed this object, which means that it's receiving the inputs from the player controller, which is like this other object that's a soul. And it's when I'm pressing W, we're accelerating. And we're also looking through that camera that we placed on the object. Let's do something else. Let's add a spring arm. A spring arm is this default component that adds some camera lag. It looks really, really good. We can attach a camera to it, and now the camera will be positioned on the end of the spring arm. In fact, let me reset its transformation. Here's the spring arm. It's like a laser pointer, and it lets us do really neat effects. For example, let me just make this spring arm. Let me make it go farther away. And additionally, let me enable camera lag and camera rotation lag. And now we'll hit play. And as we accelerate, there is some lag. You can see the object is moving further up in our vision because it's kind of accelerating away from us. It's also floating in the air, which is becoming noticeable. We're starting to see its shadow because of how fast it's going, and it's pulling way ahead of the camera now. I'm really spamming the W key here. We're running out of terrain, and off into the distance, right? So that's good. Let's add some more controls now that we figured out the whole possessing thing. Let's go ahead and make an A key. A key. A key. Gotta scroll up and find it. There it is, A. So when A is pressed, we should probably turn left. Let's add rotation. Add local rotation. Add actor local rotation. Target self. The delta rotation is going to be on the z-axis by -5 or something. Sure. And now when I press A, oh, he rotates. He rotates. The camera's not rotating, however. And the reason why is because the camera, I checked the box that said use controller rotation. Use pawn control rotation. Let's turn that off, and now it should grab the rotation of the, yep, there it is. So I press A, and I spam W, and press A, and now we're turning. I have to spam A, however. This is quickly becoming very inconvenient. I'm sure you would agree. So what can we do about that? There's actually a very different and better way to handle inputs in Unreal Engine. What we can do is, instead of doing like A and W and all that, we can go over to the project settings and create like an actual list of keybinds that will be like standard for our game. You go over here to edit, and you go to project settings, and you go to input, which is down here. And we can say axis mappings. So let's grab a new axis mapping here, and we'll call this forward backwards. What this is going to do is it's going to listen for any keys that we list here. So for example, W and the S key. Find S. There it is. And when S comes through, it'll be -1. And when W comes through, it'll be +1. And every frame that W or S is held down, an event will fire off, kind of like event tick that we were talking about just a second ago. And anything that you attach to it will fire off. And yeah, so that's actually really convenient. Let's work with that. Let's do, let's see, forward backwards. There it is. There's the axis mapping we just created. And all we have to do now is set current velocity to acceleration plus that. But we actually want to do, let's do acceleration times 1 or -1. Float times float. So this axis value is going to be 1 or -1, depending on whether W or S was pressed in the previous frame. And we're just going to multiply that by acceleration and decide that that's what we're adding to our speed. So it might start going backwards now. And now, as I hold down W, and now as I hold down S, and now we're decelerating. All right. Very nice. Very good. We got car physics kind of going for us. let's do something similar with A over here. In fact, let's add another property to our car, and we're gonna call this let's see, we'll call this turn rate, and we will say get turn rate. Let's go add another axis mapping. Let's go to edit, project settings, input, axis mapping, left, right, whatever, not even camel case, that's fine. We'll grab the A key and the D key. Typically, right is positive and left is negative. That's like the way that people seem to do things. So that's what I'm going to do as well. And then I can go over back to the car and I can say left, right. There it is. And I can, based on the output of this, I can multiply it by turn rate. So float times float. And this over here, this is a purple pin. This is a rotator. It's like a type of, it's like a vector. I mean, fundamentally it is a vector, but it describes rotation instead. And it's generally used specifically for rotation. You can drag off of any pin and you can say, there's always this option at the bottom, like make rotator or break rotator or whatever. And it'll break it up into its components, X, Y, and Z. So what we want to do is we want to do left, right times yaw. And in fact, we'll do this responsively. We'll do this the second that we press A or D, it'll immediately rotate on the Z axis by the turn rate times -1 or +1. Great. Let's do that. And it's not working. It's not working. Because turn rate is 0. That's why we never set turn rate to have a value. Let's change turn rate to 0.5. That should be degrees. So it's going to be 0.5 degrees per frame. There we go. Nice. Nice. And we can rotate in place. Very interesting. Our car is hovering in the air a little bit. That's noticeable. Let's lower it to the ground. So that's cool. We've got this little car. It can accelerate to really great speeds, slow down. In real life, what prevents a car from not going too fast? Features like drag, fighting against the horsepower and torque of the wheels. So we can do stuff like that if we want to. We absolutely can. We can give it suspension. I think Marissa actually is programmed or she had a project where she totally did like car suspension stuff from scratch at some point. So this should be vaguely familiar. But let's do a little bit of inheritance instead. I think that would be more fun. So this is the My Car class. And in a way, it has some features that are fundamental to all cars. Any car in the game should probably not necessarily have the same mesh, right? So in fact, why not? Let's go ahead and delete that and just be like, okay, this mesh. In fact, let's add a static mesh component. And let's make this the scene root. And let's go ahead and delete cube. And now we've just got this empty static mesh component that is the scene root and spring arm and camera, yada yada. And it's angry. It's angry because we removed the cube, but what we instead want is a reference to the static mesh and the static mesh forward vector and add actor local rotation. And now it's happy again. There's no errors. So there's nothing here. Let me change this from my car to a car. And then what I can do is I can right click on it and be like, okay, create child blueprint class. And I'll call this a car that can jump. And a car that can jump is just like a car. In fact, it comes with everything else that we already did. Except, check this out, it has one thing. Event tick, every frame, it calls event tick on its parent. And then we can do our own stuff. Or we can do these in different order. We can do stuff on our own and then call event tick on the parent. So what is the parent? What does that mean? It means that secretly, it's got all of this code running. Okay, it's got all that code. It's gonna work. But in addition to it, we can have our own code here, and it's got its own event tick, and it'll call the parent event tick, which is this guy, every frame. So on its own event tick, it calls what it's inheriting from that event tick, and it fires this code off, and then we can do our own stuff on it. I hope that was vaguely clear. It really wasn't, I don't think, but that's okay. Let me add spacebar, and when we do spacebar, let's add you know what? Let me just do this. I'm gonna press C, and this is commenting in Blueprint. You can add comments, which are just like ways to wrap chunks. Like for example, over here I can say static mesh, get forward vector, vector times float, vector times float. I can select all this stuff and be like, oh, and Unreal Engine's like freezing again. This is really disturbing. Shouldn't be happening. Show off's chilling. Unreal Engine's freezing. It's really great. It's so great. Wow, here we go. Any minute now, come on. Come on, Unreal. That's really concerning. I wonder if it's related to my graphics card. I sure hope not. Man, I think something's weird with my RAM, admittedly. Like, I think that might be related. I don't know. Computer's definitely had weird stability issues post-RAM. No, okay, there we go. All right. So when I pressed C, it generated this comment around it. I swear to God, they don't lag that much. And we can say like, yeah, this is move each frame. Move each frame. And then maybe over here we can be like, all of this stuff is update velocity. And the nice thing about comments is that you can drag them around, you know? So you can really break down your code into chunks that make sense. And then this is like rotate. Cool. A car that can jump. When the spacebar is pressed, the car should add. We can probably do this with a curve or a mathematical equation that's like go up and then go down. The easiest way to do this is with physics. And physics are great. What we can do is we can go over to our static mesh and we can just be like, hey, simulate physics, which it won't let us do because I don't think we've applied a static mesh. Only, oh no, it's because it's the scene root. It doesn't want the scene root simulating physics. That's fair. No, we'll do this with code. We'll do spacebar. We'll do
You could like set the velocity to like a high number, and then just constantly decrease the velocity. That might be just fine for now.
There's no vertical velocity. We can make a separate variable for vertical.
Like up. You could just do it to vector. You could find the up vector, the object, right?
Yes, but there's no there's no velocity properties to the object because it's not simulating physics. So if we wanted to give it velocity properties, we would have to add another variable called upwards velocity. And then we could, yeah, we could do like the physics calculation. That's not that bad. But I think it's even easier to do something else, which is like play curve blueprint, something like that. I'm trying to find what it is. Using curves and you get curve values. Yeah, it's something like that. Let's go back to the car that can jump. Curve values. Curve. Get curves. No, that's not quite it. If I go to variables here, and I do variable of the type curve, curve float. Yeah, curve float. And let's create a new asset. Continuum intro curve, that's fine. Let's go over here and make another, let's make a new asset. We're gonna call it curve. Where is it? Physics, no. Blueprints, no. Animation, perhaps, no. Curve. Curves are really nice. Curves let you like just not media, miscellaneous. It might have been under miscellaneous. There it is. Curve. Yep. Curve float. Yep. These are great. Jump curve. just an example of like another thing that we can do. And then over here, there it is. Jump curve. Compile, save. Let me open up jump curve, and we'll call this the position over time. Relative position over time. And what we can do is we can simply add a handle here somewhere. Asset file. How does this work again? This is a nice nice editor here. We can do control click, alt click, shift click, double click, delete, enter, enter. Enter's great. Another enter. Yeah. All right. Nice. We can give these guys handles like that and like that. Yeah. Okay. Cool. Sick. So at time 0, we want the curve to be at 0, and then at time 1, we want the curve to be at 1, and then at time 2, we want the curve to be back at 0. Cool. And a jump curve actually looks a little bit more parabolic. So what we can do is we can make these guys be linear, and this guy be linear, but this guy be quadratic. Fella. Doesn't quite do things the way that Blender does, I suppose. But the idea would be to, I suppose, make this guy, yeah, something like that. That's basically how physics work, more or less. Can even do this? Just, you know what? Let's do that. We'll see what this jump looks like. All right, and then we can go in here. We can say, where it is, a car that can jump. All right, and when spacebar gets pressed, get curve. We can do get value. Or play. Okay, curve. Let's just go over here to time. Does timer exist? Is timer active? Get timer elapsed time remaining by function name. Timer. Clear timer. Pause timer. Get timer. Timer. Play animation time ranged with finished event. Get timer is timer. Timers are an option. Play curve blueprint. Open door with timeline. Timeline. That's what they're called. Timeline. I forgot about that. Timeline. Add timeline. That's it. There we go. Okay, cool. Now, when spacebar gets pressed, this plays, and what it does is it plays at time 0, and it will play this curve, get time, get float value at what time? At the let's see, timeline. Okay. Play. And additionally, we can do variable anim time float. And what we can say is we can say set the anim time to 0 when we start. Get time. I wonder if you could do get time on the timer. Get time on the timeline or something. You can do get timeline 0 time, get timeline length, get play rate, get ignore time dilation, is playing, is reversing, get get timer elapsed time by function name. Yeah, it's not, that's weird because it obviously has this input for time. Timeline nodes allow you to be keyframed over time. Double clicking this node will open the timeline editor tab. That's what I thought. Okay, my bad, guys. Yeah, you don't do this with a curve. This is what I was looking for. Here we are. Can add a float track. There's a floating point curve, and then we can be like, okay, let's there, jump curve. Brilliant, great. Compile, and then we go back. We don't even need this. There we go, and it's just going to output the curve, and we can say set relative, or yeah, add relative, no, set height, no, add location, move to location, play sound, let's just do set actor location, set actor local offset. Brilliant. Set actor local offset, and the local offset that we will set will be on the z-axis by this curve, z. Brilliant. And now, now without further ado, instead of a car in the world, instead of my car 2 over here, who's in the ground for whatever reason. Oh no, it's just there's nothing there. We'll do this guy, and immediately we're underground. There we go. Okay. And when I hit space, oh, okay, I did it. It did it. Cool. It did a thing. Let's make sure to when it's finished, when it's finished, it should reverse. No, play from start. No. Just when it's finished, it should reset this guy. Yeah, anim time doesn't even matter here. When it's pressed, play, delete. Yeah, timelines. Timelines are a really cool little system that lets you achieve results like this. That's cool. Yeah, you know what? Let's give our car a little 3D model. I'm just gonna go over in Blender real quick and generate a 3D model. It's 5:30. We got like 27 minutes left. I hope that this has been a little bit insightful for what inheritance looks like in Unreal Engine. Let's go ahead and just do like a little bit of that and a little bit of like that maybe. That's basically a car. 0. Yeah, something like that. It's kind of how cars look. Yeah. And maybe they've got a little window thing going on where these windows are separated like that-ish, and this entire loop is kind of like that, and like that, and like maybe they do a bit of this. Cool. Cool. This is, what is this? What even? Oh god. All right. Yeah. Not great. Not great. But extrude the individual faces. Great. Maybe delete. Oh no. Let's do this. We'll maybe delete these faces and these faces, and that face and that face, and that face, and that face, and then maybe select these guys again, and maybe extrude them all, and down like that. Yeah, tires. Yeah, that's a car. That's a car. It's literally like more aerodynamic backwards than it is forwards. I guess we'll make this the windshield. That's not a windshield. This is a windshield. Yeah, cool. Give it like a cool grill, perhaps, with really inefficient geometry. Yes, absolutely. Bit of this, bit of that. Yeah, that's a car. Okay, file. Oh, is it facing the positive x direction? It's not. Let's flip it 180 degrees. Apply everything. File, export fbx, desktop, or something. Mesh, export, done, great, don't save, it's garbage anyways. Go to the desktop, grab the car. Where is the car? Untitled.fbx presumably is the car, I hope. Drag it into Unreal Engine. There it is. Untitled, import, done. Yes, that was the car. And then a car that can jump can just be like, yeah, specifically a car that can jump is going to be a car that uses that static mesh. Car, was it? No, it's called Untitled. Untitled. There we go. Great, nice. Save that, and then hit play again. Does the animation, doesn't do it again. Nice. Car turns. I mean, you know, what more could you ask for? Like, this is basically Forza. Yeah. EA's got nothing on us. What you could do is you could vary the turning rate by the like velocity. You could give it drag, where there's a force applied in the opposite direction of velocity every frame, or not a force, but just, I mean, it's just another vector. So what you can sort of do is you can say like, hey, every tick, the relative location that we're going to move, the direction we're going to move, is going to be the sum of all of our velocities. Not just the forward vector, but it should instead be the sum of both our acceleration and drag force. So we can do like add this to drag, or what we can do is we can make a function. Let's make a function. We're going to call this sum velocities. Yeah, sum velocities. And sum velocities is going to take an input, and that input is going to be a vector, and that vector is going to be, hell, we can make it an array. Array of vectors. And we're going to call this input velocities. And the output is going to be the for each loop, and for each array element, we're just going to make, okay, vector. We can't really do this with vector literals, so we'll do a variable real quick, and we'll call this summed velocity, and make it a vector. And summed velocity will be set to whatever summed velocity already is, plus the array element velocity. And then when this is done, it will, well, when it starts, actually, hold on, when it starts, we should set summed velocity to nothing. And when it finishes, we should output, or function, what is it, function end? Where's the end node? Or should we have outputs? Sum velocities. This function should have an output. Yeah, here we go. And the output is going to be a single velocity vector, total velocity. Great. Compile, save. And then we're going to just return the function with whatever summed velocity is. I think you can do local variables. There's got to be local variables. Maybe, maybe not. It's possible that's not a thing. I would have hoped it is, but it might not be. So there we go. Some velocity, I guess. That's really weird, actually. There's totally a way to do that, but that's all right. Yeah, let's go back into our event graph, and what we can do is we can simply do summed velocities, and what we can do is we can append array, add. Okay, great. We need to provide a reference to an array. What we can do is array. Make array. There we go. That makes a literal array. And this array will be made up of both. There we go. Just like that. This array will be made up of both our forward vector, and we can also grab our current velocity, float times vector, float times vector, vector times float. There we go. We can multiply our current velocity. We can square it first. So float times float, I guess, and we'll just multiply it by itself. So drag is a function of velocity squared. In the opposite direction of the forward vector, so we can do get forward vector of the same static mesh. Doesn't matter. We can pull another one over here to keep the coding, I guess, looking clean. Get forward vector. Vector times float, -1. So that's the backwards vector, and velocity squared times that. Vector times float, this would be the drag coefficient. We'll call this like 0.2, and we can put that right there. And now we should have drag, hopefully. Let's see how this works. Okay, W is doing nothing. A is doing stuff, but W is doing absolutely jack nothing. That might be for a number of reasons. We're summing these vectors. The vectors are current velocity squared, which is 0. So originally it starts as 0 times whatever, it's still 0. That array goes in to input velocities. Then we do for each array element. Oh, we don't. Right. I'm stupid. There we go. There we are. That should work. Compile, save. There we go. And now, if I take my hand off of it, it's slowing down. I can tell it's slowing down. It's moving slowly towards us. There's a little bit of drag. We can crank up the drag coefficient quite significantly. And now all these properties are associated with a car that can jump, by the way. The other car doesn't have these. And we can inherit from a car that can jump and whatever, make like a Lamborghini variant that has a different static mesh, that has a different, like, look and feel, if we wanted to. Let's crank up the drag coefficient on the car that can jump, however. Where is our... Jesus, where's our... where's all that code? Where'd it go? Event graph? Oh, was I doing that in a car? I think I was. Right, so yeah, when you update stuff in the original thing, whatever's inheriting from it receives those properties. So the only thing that a car that can jump has on it is the fact that it can jump. My bad. Let's make the drag coefficient a much bigger number. Let's make it like 10. Now, drag should be a big function against us. I take my finger off and it's... okay, it's slowing down. But the funny thing is that what drag should be doing is it should actually be subtracting from velocity each frame, not being the sum, because then velocity never decreases, like velocity is a static thing. So that was a poor implementation of drag, but it is having an effect there. It's kind of slowing us down. I guess it does create an asymptotic top speed that we can theoretically reach. So that is interesting. It does kind of work. Yeah. Unreal Engine, inheritance, has inheritance where you instantiate other objects inside of this object that we've created. Is inheritance where we create a car that can jump that inherits from a car and lets us do this. Oh, there it goes. It floated up into the air. We could probably give it a much more ridiculous curve that has a much more pronounced effect. So something like this. Oh, what a jump! What a jump! That car jumping. Yep. And give it like some near infinite upness and downness. Let's see. There we go. Yep. Yep. That did it. So yeah, that's a bit of programming in Unreal Engine. You can do object-to-object communication. There's like a billion events that you can reference. So, for example, like if the player were to shoot something, you can draw a line from where the player shot. It's called a line trace, and you can see what it hit, and you can be like, "Hey, is that a player?" And then apply damage to it. There's literally so much to this, but as long as you understand those object-oriented concepts, you can make whatever you want. The only other thing that you just sort of have to learn from experience is the Unreal Engine API. And the Unreal Engine API is like all of the functions that come with Unreal Engine. So like the ability to fire a laser and see what it hit, the ability to identify if two objects collided. These are things that the engine handles for us and lets us utilize to achieve whatever results we want. Works the same way in Unity. Yeah. Yeah. This has been fun. I hope.
So, Michael, before you start headed out,
Yeah.
if I wanted to make a car with a similar like property with the with this car, or if I wanted to make any other object, right,
Mm-hmm.
with the same or similar properties with a car that can jump, right, or just a car in general.
Uh-huh.
So since in Unity, since in Unreal, it's more of like is a relationship, right? Because like you make the script on the actual object itself, right? Um, like you create this object, and then the script is automatically attached to the object, like that object is the script in a way. It's like it's weird.
Yeah,
Um,
yeah, I suppose, yeah. All the
yeah, no,
code pertaining
it's a
to
little bit of different. It's a different paradigm, which is fine.
it's a more natural paradigm. This is how things work in code in general. Like you have an object, and that object contains like the functions and the variables. That is how programming normally works. Not like sort of attaching scripts. That is the like Hasa stuff, where in Unity you never really touch the code of the game object itself. Instead, you just give it like scripts that can reference the game object, and the scripts look like these things here.
Yes.
But
Well, like
that's yeah.
best way to compare, I guess, it would be like in this, like I would like I guess like a car would be the prefab, I guess in Unity, like how I would consider it would be the car would be the prefab because you could just drag it from the inspector into the actual scene or whatever it's called in Unreal, right?
Mm-hmm.
But like if the components would be more like making a new event graph and then having that like each for each thing you wanted to have happen. Right, so like in the graphs, like you would add, like a new component would be like a new event graph, and then you would do everything. It would each have their own tick and like
Yeah.
start and stuff like that. So like that for the comparison, I guess, right? But I'm just asking, since this is less component based, where like if I wanted something else in my scene to have the same jump property, how would I do that?
The same
Look,
jump property. So
yes,
okay.
same jump, yes.
So if you want to give multiple things the ability to jump, I suppose you would do that with an interface, just like you would with like raw C++. So what you can do is you can do like
How do you
blueprint.
implement that? I'm curious.
Do you know what an interface is?
Yes, I do.
Okay. So you can actually just go here to blueprints and be like, hey, blueprint interface, and we'll call this the jumpable object, and then you can go in here and be like, okay, let me create a new function, new function 0, and this new function we'll call it give it an input, and we'll say jump height or something. I don't know, float, right? Sorry, float type. We'll call that jump height. Yeah, and then on other objects, we can just implement that. So we can go over here to class settings, and we can give it an interface that it implements. So we can, not AI. No. Jumpable object. And now that it implements that, we have access to like that function in here, and we can say what happens when this function was not marked as blueprint callable and cannot be placed in the graph. Let's go back. This guy should be call in editor. Yeah, pile save. Bruh. Okay, hold on. Enable this event to be called within the editor. Yeah, right. Outputs. I haven't done this in a second. Hold on. Class settings, jumpable object. Yeah. What? Class settings, jumpable. In fact, an interface might not actually even be the appropriate way to do this. I hope it is though.
I would think it would be, because if it's just like, but if interface doesn't have an implementation, I guess, right? It's
Exactly. All it says is like, hey, yeah, this object can receive this function.
Yeah, it's like an abstract class, but like, just like straight up.
There it is.
Can have multiple inheritances.
There it is. New function 0, and now we can call this function on the interface. We can have this function called on us, I suppose. You can do like event dispatching. That's one way to. Oh, and Unreal Engine's crashing again. What is going on, man? That is, my whole computer's crashing. My mouse is frozen. Can you guys hear me?
Did you freeze?
I think Michael died.
Yeah. His
The rest
computer's
is-
melting as we speak.
Hello. Hey, yo.
Oh, there he is.
Yeah, whole computer
Resurrect.
just froze. Oh, and it's happening again.
I get you though. I wouldn't worry too much.
What the fuck is happening right now? Oh
That's
my
cool. I just was like curious, like
God.
how did that work? Because I was like, hold up, if everything is a prefab, and that prefab has its own scripts. Oh, did he crash again?
Yeah, I think his 3080 Ti finally burned the hole.
I'm
in
talking
his
to
floor.
dead
Yeah,
Michael.
no, he's out of here.
No, I can hear you guys. I can hear you guys.
Fat GPU falling through a ceiling right now.
It's
Yeah,
not my
you
graphics
can
card.
see.
I can hear you guys. God, I literally can hear you
Well,
this
does that make
entire
sense?
time.
Does that have this? Is for people who have used Unreal and Unity? I guess like Julian. I guess both of you. Does that interpretation line up with what
What interpretation?
Unreal actually does? Where like every object, I guess, is a like a prefab, right?
The prefabs feel like a blueprint in itself is like a prefab.
Yeah, yeah.
That seems to be the best way
yeah.
to describe it. Like, they're very similar in functionality.
It seems like that. I mean, obviously, I've never used Unreal, but it definitely. I mean, it seems like that. I think I forgot what the name of. No, yeah, they called it blueprint. Like at our like the discussion the panel when they were talking about Unreal.
I'm back.
Is he?
When you change the object, like when you change a feature of the object, every single instance of the object changes. It was in essence what a prefab is. So I'm gonna say probably.
I'm somehow
kinda
back.
cool.
Hello, sorry about that.
Kinda cool. It's like sorry, but like it reminds me of like it's like Unity, but like new input systems already implemented. Everything's a prefab, and like multiple like interfaces and stuff. I don't know. It seems kind of cool. I couldn't follow along with the tutorial. It was a bit fast.
It was, I know, it certainly was, certainly was. The Unreal crash was really interesting. It told me multiple pure virtual function being called while application was running. GI's running is equal to 1. Something to do, I think, with my graphics card simultaneously doing like screen sharing on Discord, doing hardware encoding with NV encoder over on Streamlabs, and then might have somehow been attempting to do RTX or something. Like I don't know, but my GPU's fine. Like it's not overheating or anything. It's chill. So very disturbing. Very disturbing. God. Anyways, just yeah, that's that, guys. I hope that was somewhat insightful on like inheritance and stuff. I hope it's insightful to just new people. Comparing Unreal and Unity is kind of weird with how the paradigm is in Unity with just like appending scripts to objects. That's really weird to me. Like it's kind of disturbing to me, honestly. I don't like that. That's really like.
Well, like having every object have its having every script be its own object is kind of disturbing to us. So.
Yeah, but that's how it is in like all programming though. That's the idea. You take an object and you encapsulate it. All the object's code is like the object. A class has functions and variables, and that's how it works, you guys. The class then instantiates a static mesh inside of it or something else. But in Unity, it's like a game object has scripts, and then the scripts do other, like, oh god, I'm not a...
I feel like it's like trying to do like a layer of separation between the actual like visual and like the more of the component scripting side. But like on Unreal, like it's just one actor, you know what I mean? It's just like one like entity, which makes sense in terms of like actually using it. Like like they're just different ways of doing it. It's like
I really think that the Unreal Engine way is better.
The Unity approach is much more beginner friendly because it makes like a lot of. So you have a game object, and it's like, okay, let me create a script to do movement, and then I could put it on the game object, and then I can call different properties and components of the game object within the script that's attached to the game object. And then it's like, all right, now I want an attacking script on this game object. Now I can put another script, and it kind of modulates it in a very has a sort of inheritance.
In Unreal Engine, you can do functions inside of the event graph and achieve the same thing in a way. Like it's...
Yeah, but it's a little harder to look at an approach as opposed to like the very like it's almost like a Lego like setup that Unity has going. It's very
you can definitely like create a function library that lets you like reuse like a function all over different objects. By the way, to answer your question, Alex, like we probably should have done that with a function library, and the function library would have taken a reference, and it would have taken a static mesh reference. So it's like, okay, I take an input as a static mesh, and when I'm executed, I move that static mesh up and down, and that's the jump function. And
like I would think of it like
distribute
more
that.
like you take the actual like reference of the variable that's moving the object, and then every time you would in the update you just adjust the actual position to what that variable says. At least that's how I think of it more. If that makes some sense.
I'm just saying we would do that. Yeah, that's what we did. That's what we did. You saw the little timeline thing, right? So the timeline, like the timeline is really just like a for loop, pretty much. That it's asynchronous. Unreal Engine does handle asynchronous stuff. So there's a bunch of asynchronous programming that you can do, like multi-threads stuff. But yeah, that little timeline thing, I believe, executes asynchronously, and just runs whatever chunk of code you attach to it, which in our case was like add relative location to the actor. And what you can do is you can put that in a function, is what I'm telling you, and then you can put that function to any number of blueprints, just like you would put a script to game objects. But putting functions to blueprints is a little more, I don't know, puritanical. Like it feels like how coding normally goes. Like it's how C++ is. You know, you create a function library and then you reuse a function with like I can't imagine, like I don't know how a Unity script would work. Like you would drop that script, but then wouldn't you have to go into the script and be like, okay, no, now you're referencing this new object that I put you on? Like, how does it, is it just like get the owning object and move it up and down?
Yes.
Okay, so that's what we're doing. Yeah, that's exactly what this would be then. Just like a little function that gets the owning object and moves it up and down.
Oh yeah. There's a bunch of Unity has this very what's it called? I think it's just called game object. Like, okay, so there's
Yeah.
game object, which is the game object like as like a thing that is in Unity.
Mhm.
It's a
And then
transform.
when you're
It's a
Actor.
scale-
Actor.
when you're typing
Actor.
the actual code, there's a camel cased game object where there's a lowercase g, and that will always reference the actual thing that the script is attached to,
Mm.
like all the time. So you just literally use
Yeah.
that. You could get the transform, the rotation, the position, blah blah blah. blah
In
everything
in
about that up.
in Unreal, you can just right click and be like get reference to self, and it'll get you that.
Yeah, it's essentially something.
yeah.
Yeah, it's basically like that.
Yeah.
That's how
Kind
it
of the
kind
same
of
thing,
modulates it.
It's identical. It's identical. Yeah. So not too different. Not too different. I hope that was good. I'm gonna end the recording here. We can keep talking. Cool.